This video, we're going to analyze the graph of some quadratic equations here. So we've got parts A through C that we're going to work on. First question here is whether this parabola is going to open up or down. And it's going to open down because the leading coefficient here is negative. Now it wants us to put it in vertex form. So we'll have to come over and complete the square. When I factor out the -1, inside the parentheses is going to be x squared plus 8x. And I'll have some space and something to write on the other side. Half of 8 is 4. 4 squared is 16. I just added a -16 into the problem, so I need to add a +16 to balance it. And this is an x plus 4 squared plus 16. So my vertex is at a -4, +16. So I'm going to put that point right there on the graph. I may also want to factor this to find the x-intercepts. So -x squared minus 8x has a common factor of -x, x plus 8. So there's going to be an x-intercept at 0 and an x-intercept at -8 right there. I also have a y-intercept at 0, 0. That doesn't help me, but the vertex of the parabola as an ordered pair is -4, +16. The equation of the axis of symmetry is x equals -4. That's this line right here. You're not actually going to make that part of your graph, but that's just things are symmetric here. So you see that this point is 4 to the right and that's 4 to the left. The x-intercepts are at -8, 0, and 0, 0. So, and then we would go ahead and my labs would help us graph this. I'm just going to give a rough sketch of what this would look like. Very rough sketch. And it would open down like that. The domain and range, the domain of any quadratic function is always -infinity to infinity. And because this one opens down, it has a maximum at, I believe that was 16. It's going to go down to -infinity because it's opening down. Function is increasing on the interval from -infinity to -4, and then decreasing on the interval from -4 to infinity. Those are x values. So we're going uphill, and then we're going downhill. And it changes at its maximum, or at the axis of symmetry. All right, let's go ahead and look here. This one is going to open up. Right? And the vertex is going to be, let's complete the square. Half of 1 is 1/2. 1/2 squared is 1/4. So we're going to have to make a common denominator here. Now remember, you can use your vertex formula as well to get the vertex. I'm just practicing completing the square because we talked about how important that's going to be. But if I had instead said that my vertex was at -b over 2a, I'd get my -1/2. Then if I stuck that -1/2 in for x, I would get 1/4 minus 1/2 plus 3/1. It's going to be 1/4 minus 2/4 plus 12/4 is going to be 11/4, and I can get my vertex that way. Let's go ahead and look and see if I can identify any x-intercepts here, if this is factorable. Might need to use the quadratic formula. But from what I see, if I would keep going here to try and solve for x and set this equal to 0, that it's going to be the squared part equals a negative. And that doesn't happen, so there's going to be no x-intercepts. The y-intercept is going to be at y equals 3. It really is a point though, 0, 3 on the graph. So we have that point there. We have the axis of symmetry here at x is negative 1/2. And negative 1/2, 11/4, so that's almost 3, but it's 2 3/4. So 2 3/4 is right there. And then I go 2 tick marks to the left, go up 1 tick mark. My parabola should be up here. It's opening up, and you'll see that it does not cross the x-axis, like I said. Determine the domain and range. So the domain is again going to be negative infinity to infinity. And the range is going to start at 11/4 and go up to positive infinity. Determine where it's increasing and decreasing. It's decreasing from negative infinity to negative 1/2 is my, yes, it's my x value for my axis of symmetry, and then it's increasing from negative 1/2 to infinity. Now we have another example, x squared plus 8x plus 7, which breaks down into x plus 1 times x plus 7. So we're going to have x-intercepts at -1 and -7, 1 and -7. Okay. My vertex is going to be at negative b over 2a. It's going to give me a -4 for my axis of symmetry. And when x is -4, y is -9. I just used the factored form. It was easier there. And so the vertex is at -4, -9. The x-intercepts are at, and it says to use an integer. So they are at -1, -7, and -1, but we really should write intercepts as ordered pairs. So this is really -7, 0, and -1, 0, but my labs gave the instruction to write an integer or fraction. So I need to go back up here and fix that for this problem. I forgot to give the y-intercept on that problem. The y-intercept is at 0. This is, they just want -8 and 0. Okay. Point on the graph for when y is 7. So we're going to say x squared plus 8x plus 7 equals 7. X squared plus 8x equals 0. And I can factor, and we get our solutions x equals 0 or x equals -8. So we can come down here to -7 and say that +7. And we can say that that's when x equals 0 or x equals -8 right here. So those are additional points that are going to be on my graph. I've got 5 points to help me sketch this graph, which is usually what I want. It's pretty good right there. And answers as comma separated. So -8, 0. And then we've graphed a sketch by hand, but you'd have a graphing tool that would help you graph that better. It would ask you for the vertex and then one additional point, and it would draw the parabola for you. I think I have one more here. Yes, I do, just one more. So x squared plus 4x minus 5. That factors into x plus 5, x minus 1. So I have -5 for an x-intercept and +1. And I have a y-intercept at -5 because that's the constant part when x is 0. Let's look for writing this in vertex form. It's 4x something minus 5. Half of 4 is 2. 2 squared is 4. This is going to be x plus 2 squared minus 9. I have -2, -9. Like so. X-intercepts are at -5 and +1. Where is the graph -5? You'll notice that they're picking the place that equals this constant here. One of them is going to be the y-intercept. And they want you to get the other point that is symmetric here to it, which is going to be at -4. So there's my 5 points that I can sketch my graph. These are at -4 and 0. And then use the graphing tool. And that was it for this topic. We will come back next time and we will do some more graphing of quadratic equations. So we'll just start off with the equation, and then we will have to do all this, but won't be told to do it in little parts. So basically the same thing, but we just won't be told what to do. We'll just need to know what to do next time. All right. I'll see you for the next video.